They say that knowledge is power. With the RIDGID SeekTech SR20, you'll know more about the signal than with any conventional receiver. So you'll have the power to recognize problem situations and take corrective action for the most accurate markouts possible. Right now, we'll show you the features that make this possible. The SR20 operates on 4 C-size batteries. To install the batteries, locate the battery compartment on the bottom of the receiver and turn the locking knob a quarter turn to release it. Install the batteries with the correct polarity, as shown on the label inside the battery holder. You can use either alkaline or rechargeable batteries, but to prevent damage to the receiver, never mix rechargeable and standard battery types. When you've loaded the batteries, slide the holder back into the receiver and turn the locking knob a quarter turn to secure it. The batteries are installed, so let's power it up and take a look. The power key is located on the bottom right side of the keypad. We'll hit it, and after a few seconds the operating screen will come up, RIDGID, and we'll be ready to go. There's a lot of information on the screen, so let's start with the basics. The display has 2 main regions, the area outside the circle and the area inside the circle. The area inside the circle is called the active view area, and it's used to display visual elements like the map, as well as operating menus. Outside the circle, we'll find indicator icons and numeric readouts. We'll cover most of the display items in later segments, so for right now, let's look at the operating mode and frequency indicator on the left side of the display. The number tells us the receiver is set to 33 kHz, and the icon under it tells us that this is an active line tracing frequency for use with a transmitter. If this isn't the frequency we want, we can switch to another one by pressing the frequency key. Every time you hit the key, it'll go to the next frequency until you get back to where you started. The receiver ships with all the line trace frequencies turned on and all the SON frequencies turned off. If you want to turn on the SON frequencies or turn off any of the line trace frequencies, you'll need to open the settings menu. You'll do that by hitting the menu key, which is right above the power key. So let's hit the menu key and open it up. The menu opens to whatever frequency you've got selected, in this case 33 kHz. The SON frequencies are at the top of the menu, and we can get there by pressing the up key. Let's say we want to turn on 512 Hz SON mode. We'll just press the up key until it's highlighted. We can tell it's a SON frequency because of the icon next to it. There's also a box next to it. The box is empty right now, which tells us that this frequency is not turned on. To turn it on, just hit the select key. When you hit the select key, it'll put a check mark in the box, which means the frequency is turned on. To turn it back off, just hit the select key again. That's it. The receiver ships with just one SON frequency available, 512 Hz, but you can add other frequencies to this menu, and we'll show you how to do that a bit later. Let's take a look at the rest of the menu. If you scroll down a bit, you'll come to the active trace frequencies. These frequencies are designated by an active trace icon and are for use with a SeekTech transmitter or line illuminator. If we go down a bit farther, we'll come to the passive power trace frequencies. These are designated by a power icon and are for tracing 50 or 60 Hz power line signals. The next set of frequencies are for passively tracing RF or radio frequencies, and they have an RF icon next to them. At the bottom of the menu, you'll find some tool settings. The first item lets us switch the depth measurement between feet and meters. Just press the select key to switch back and forth. The next item controls how the LCD's backlight works. It's on automatic right now, which works well most of the time. You can also turn it on all the time, or have it off all the time to save your batteries. And here's a quick tip about the auto backlight feature. The auto backlight sensor is at the top of the keypad. If you cover it up, you can sometimes trick the backlight into coming on. This is the easy way to get the backlight to turn on if you just need it for a few seconds. The next item on the menu lets us change the display's contrast. Just press the select key, then use the up and down keys until the display looks the way you want it. When you're done, press the select key to get back to the main menu. The receiver has some advanced display features, and the next item down lets us turn them on and off. The first time we press the select key, we'll get to a submenu with 2 choices, line or SON. Line is already highlighted, so let's press the select key to open up the control. There are several different display elements here. We'll cover a few of these later on in the video, and all of them are covered in the manual. So for right now, we're just going to show you how to turn them on and off. Use the up and down keys to highlight the different display elements. You turn things on and off by pressing the select key to check or uncheck their boxes. When you're done, press the menu key to get back to the main menu. A few minutes ago, we told you that you could add additional sound frequencies to the main menu. The next item down is where you can do that. Let's open it up and have a look. The top item has a sound icon in it. We'll highlight this choice and hit the select key. This takes us to a submenu that contains all the sound frequencies that are programmed into the receiver. If there's a check mark next to a frequency, that frequency will be available in the main menu. But if it's unchecked, the frequency will not be available. 512 Hz is the only one checked, so let's uncheck it and see what happens. We'll go back to the main menu and go all the way to the top. As you can see, the only sound frequency we had is now gone. And if it's not here in the main menu, it won't be available when you hit the frequency key. If we want it back, we'll need to go back into the submenu and turn it on again. You'll notice this menu also has choices for active, power, and RF frequencies, and they work exactly the same way. This feature lets you unclutter the main menu by getting rid of frequencies you never use, and it's great if you know how to use it. So now if you loan your receiver out and it comes back missing some frequencies, you'll know how to put them back. The last menu item contains a screen with information about your receiver, and a menu item that lets you restore your receiver to its factory default settings. Select the X icon to close the menu without making any changes, or the check icon to restore your receiver to its factory default settings. That's about it for the settings menu, so let's make it go away. Just press the menu key until all the menus are closed, and you'll end up back at the operating screen. There's one more key we want to look at here, and that's the volume control key. You'll use the volume control key to control the sound level coming out of the speaker. The key works two ways. You can press it repeatedly to cycle up through the sound levels, or you can press it once to open the sound menu, then use the up or down keys to change the sound level. Like all menus, it will close on its own, or you can press the select key to close it immediately. The SR20 has several features that help make line tracing fast and efficient, and in this segment, we'll show you what those features are and how to use them. Our technician will position himself directly over the utility, and we've marked the utility's position to make it easier to see. His receiver's on, and it's set to 8 kHz, so let's see what his display looks like. If the display looks empty, it's because we've turned off most of the display features. We'll take a look at the ones that are here, and then turn the rest on one by one. We showed you how to do this in the segment on setting up the receiver, so refer to that section if you need some help. Outside the active view area, starting at the top, we have the proximity signal number, operating mode and frequency, depth, and battery life. Let's take a closer look. The proximity signal looks and acts like the signal strength or peak signal you may be used to, but it's based on a completely different measurement. What you need to know right now is that you'll use it the same as you would signal strength, and that in most cases, it will give you a truer indication of the target signal's position than signal strength would. Using the proximity signal is pretty straightforward. The closer you get to the signal, the higher the number gets. When you're directly over an undistorted signal, the proximity signal number will be highest. And as you move away from the signal, the number will decrease. The proximity signal isn't affected by the receiver's orientation to the signal. So even as we rotate the receiver, the signal stays fairly constant. You've already seen the frequency and operating mode indicator, so we'll skip down to the depth readout at the bottom left of the display. The depth updates continuously as you locate. It will be lowest when you're directly over an undistorted signal, and will increase as you move away from the signal. There are two important things to remember about the depth reading. First, the receiver is actually measuring distance, not depth. The reading only reflects the depth of the target signal when you're directly over it, and the receiver is vertical. The other thing to keep in mind is that the reading reflects the depth measured by the receiver, which may be different from the utility's actual depth. The only way to be sure of the utility's actual depth is to expose the line. At the upper right of the display is the battery life indicator. If the indicator is completely filled in, your batteries are full. If it's empty, it's time to change them. Next, let's take a look inside the active view area. The first item we'll look at is the crosshair in the center. The crosshair represents your position relative to the target signal. The other item inside the active view area is the tracing line. The tracing line has three important functions. It represents the location and the direction of the signal you're tracing. It reflects changes in the direction of the target utility, like when the utility makes a turn, for example. And it helps you recognize signal distortion. Let's see the tracing line in action. When we're directly over an undistorted signal, the tracing line will be centered on the display like you see here. If we move the receiver to the right, the tracing line moves left because the target utility is now on our left. If we move left, the tracing line moves to the right. And here's another thing. The tracing line will stay aligned with the signal even as we change the receiver's orientation to the signal. And that's true whether we're over the signal or off to one side. The tracing line operates independently from the proximity signal and is based on an entirely different measurement. Because of this, we can compare the tracing line against the proximity signal to evaluate whether or not the signal is distorted. Here's how. When the proximity signal is highest, the tracing line should be centered on the crosshair. In other words, if the tracing line is centered, like it is here, and we move the receiver to either side of the target utility, the proximity signal should decrease. In this case, the tracing line is centered when the proximity signal is highest, and since both measurements are in agreement, we have a strong indication that we're dealing with a good, clean, undistorted signal. The tracing line has a special feature that lets you see signal distortion visually, and we'll open up the settings menu and turn that feature on next. When we get back to the operating screen, you'll notice that the tracing line is now distorted. This tells us that the signal we're tracing has some distortion. Here's how it works. The tracing line's position and direction is based on the angle of the signal passing through the lower antenna, and its sharpness is based on the angle of the signal passing through the upper antenna. If the signal looks the same to both antennas, the tracing line will be sharp. But if the upper and lower antennas see the signal differently, the tracing line will be distorted. The audio tone also changes based on the tracing line's appearance. If the line is sharp, the audio will sound clear. But if the tracing line is distorted, the audio will contain static. In general, the greater the difference between the two antennas, the more distorted the tracing line will be, and the more static you'll hear in the audio. The important thing to remember is that this feature is merely a tool to help you recognize signal distortion, and you cannot base your locate just on the sharpness of the tracing line. Even if the line is sharp, you still need to compare it to the other readings to determine whether or not you can get an accurate trace, and we'll show you an example of this in the next segment. The next display element we'll turn on is the guidance arrow. The guidance arrow lives in the center of the display and provides the same type of measurement as a conventional receiver set to differential mode. When you're directly over an undistorted signal, you'll see a two-headed arrow centered on the display. When we move the receiver to the right, the arrow extends out from the center of the display, pointing back in the direction of the signal. As we sweep back towards the signal and then cross over it, the arrow shrinks and then grows out in the other direction to reflect our movements. The guidance arrow operates independently from both the proximity signal and the tracing line. Because of this, you can compare it against them to evaluate the signal for distortion. Just like the tracing line, the guidance arrow should be centered on the crosshair when the proximity signal is highest. So if the guidance arrow is centered, and we move the receiver to either side of the target signal, the proximity signal should decrease. You'll also notice that the tracing line reflects the movement of the guidance arrow, and that both are centered on the display when the proximity signal is highest. That means we have three completely independent measurements that are in agreement with one another, and that gives us even greater confidence in the quality of our signal. There are two additional items to note about the guidance arrow. First, it's the only measurement where the receiver's orientation matters. Its signal is measured by the two circular antennas near the bottom of the receiver's mast. These antennas must be aligned with the signal for the guidance arrow to be accurate. Fortunately, that's easy. Take a look at the tracing line. When it's straight up and down, the receiver is in line with the signal, and the guidance arrow will be most accurate. The second thing we want to point out are the special audio tones associated with the guidance arrow. When the signal is on your right, you'll hear the normal audio tone. When the signal is on your left, you'll hear a pinging tone along with the normal audio. When the arrow passes over the crosshair, you'll hear a double beep. These tones let you work without having to keep your eyes glued to the display. Next, we'll turn on the proximity signal graph. The proximity signal graph lives in the circle surrounding the active view area. It gives you a visual representation of the proximity signal, so it's easier to see small changes in the signal when you're fine-tuning your markout. The marker moves clockwise when the proximity signal increases and counterclockwise when it decreases. When the signal decreases, a watermark stays behind to give you a visual reference of where the reading was highest. The next feature we'll turn on is the signal strength readout. You'll find the signal strength icon and numeric readout at the bottom of the display. The signal strength reading is completely independent from the proximity signal, tracing lines, and guidance arrow, which means we can compare it to them to evaluate the signal for distortion. If the signal is not distorted, the signal strength should be highest when the proximity signal is highest, and the tracing lines and guidance arrow are centered. And it should decrease as we move away from the target signal, which it does. This gives us a fourth way of confirming that our signal is not distorted. The display has a few other elements, but we'll save those for the manual. Right now, let's see how the audio works. The audio tone reflects what's happening with the proximity signal. When the signal decreases, the audio pitch decreases. When the signal increases, the audio pitch also increases. If the pitch is at either end of its range, you can reset it to the center of its range at any time by a long press on the select key. Now that you've seen the display elements, let's look at the basics of tracing a buried conductor. We'll be tracing the signal that we will apply to the tracing wire of a poly gas line with a SeekTech line transmitter. But the same principles apply if you're tracing a passive power signal or a signal that's been applied inductively. We'll start by driving the transmitter's ground stake as far into the soil as possible and connecting one of the transmitter's leads to it. Then we'll connect the transmitter's other lead to the tracing wire and work the lead's teeth into the wire to ensure we have a good connection. Once we're connected, we'll turn the power on and select a suitable frequency. In this case, 8 kHz. The transmitter is beeping steadily, which indicates we have a good connection that's allowing plenty of signal onto the line. Now that our transmitter is set up, we'll turn our receiver on and select a frequency to match our transmitter. It looks like we're picking up a strong, stable signal, so we're ready to begin our trace. We'll start by positioning ourselves over the target signal and finding the point where the proximity signal is highest. If you look inside the active view area, you'll notice that the guidance arrow is centered on the crosshair, but the tracing lines are not. This indicates that we have some signal distortion. Since we're near the transmitter and also near a turn in the line, some amount of distortion is to be expected. To get a feel for how much signal distortion we're dealing with, we'll center the tracing line. In this case, we only have to move the receiver a few inches to get it centered, which tells us we're not dealing with a highly distorted signal. For this example, we just want to follow the signal to see where it goes, so we're not going to worry about this small amount of distortion. We'll keep the solid tracing line roughly centered on the display and start walking. After just a few feet, the tracing line begins to rotate. This tells us the gas line is making a turn. We'll keep the tracing line roughly centered and let it lead us around the turn. We'll follow the signal by keeping the tracing line roughly centered as we walk. Notice that we're not swinging the receiver back and forth across the line. Swinging the receiver while you walk is not recommended. You only need to move the receiver across the line when you stop to verify that the signal is clean and free from distortion, like you do before you mark the line's position. We've covered a lot of information in this segment, but the key point to remember is this. If the receiver's on-screen readings are all in agreement with one another, there's a high probability that you have a good locate. But you can never be certain of the utility's location until you expose it prior to digging. The SR20 makes it easy to get a precise markout on a remote transmitter or sonde. And in this segment, we'll show you how to pinpoint a sonde's position quickly and accurately. The sonde will be locating as part of a SeeSnake video pipe inspection system. The sonde is located inside the spring, right behind the camera head, and operates at 512 Hz. We've put the camera into a drain line that tees into another line after about 8 feet. We've pushed the camera just past the tee, which in these conditions should be well within range of the transmitter's signal. We've turned the camera's transmitter on and set the receiver's frequency to 512 Hz sonde mode. The sonde's location is marked with tape, and our technician has positioned himself directly over it, so let's have a look at his display. The items outside the active view area work the same way as they do in line trace mode. The number in the upper left is the signal strength reading, and although it's based on a different measurement than the proximity signal used in line trace mode, it works the same way. It will be highest when you're directly over the sonde, and will decrease smoothly as you move away. The depth reading also works the same way. It updates continuously as you locate, and will be lowest when you're directly over the sonde. And just as with line tracing, the depth reading is actually indicating distance, not depth. The reading only reflects the sonde's depth when you're directly over it, with the receiver held vertically and the lower antenna resting on the ground. Next, let's take a look inside the active view area. The map uses icons to represent the position of targets underground. There are two types of targets: poles, which occur at each end of the sonde, and the equator, a plane or imaginary line that passes through the center of the sonde and stretches out on both sides of the sonde until it is so weak the receiver can no longer see it. When the sonde is lying flat or horizontal, and the ground above is also flat, the equator will be located halfway between the poles, and if you draw a line between the poles, you'll find the sonde where that line and the equator intersect. The receiver's display uses icons to represent the position of the poles and the equator. We can map these points by targeting their icons on the display. Now that you're familiar with the receiver's interface, let's locate our sonde. We're going to demonstrate a basic technique that can be boiled down to just 3 steps. Localize the sonde, pinpoint its position, and verify your result. We'll localize the sonde by determining its general direction so we can get close to it. Then once we're close to it, we'll further localize its position by finding and marking the poles. To find the transmitter's general direction, we'll extend the receiver and sweep it slowly in an arc. Keep an eye on the signal reading. When it's highest, you'll be facing toward the sonde. We have its general direction, so we'll lower the receiver and start walking. As we approach the sonde, we'll pick up whichever pole we're closest to. We'll move toward it, center it on the crosshair, and place a marker chip on the ground to designate its position. After we get our first pole, we'll see a double line on the display. This line shows us how the transmitter is lying underground, and in most cases also represents the pipe's approximate direction. We know the second pole is on the far side of the transmitter, and we believe that the transmitter is to our left along this line. If we're right, the signal should increase as we move in that direction, which it does. The equator lies between the 2 poles, and we'll pass over it on our way to the second pole. We'll find the second pole and mark its position. At this point, we've localized the sonde to a position that is somewhere between the two poles and directly in line with them. To pinpoint the sonde's position, we'll line the receiver up between the poles and head back to the equator. We'll center the equator on the display and mark its position. To verify our result, we'll make sure that the signal drops off when we move the receiver in any direction away from this point, which it does. This last step is very important. Here's why. When a sonde is horizontal, the equator will be centered over the sonde. But when a sonde is tilted, the equator will be offset, often by several feet. Unlike the equator, the signal reading isn't affected by the sonde's tilt, and that's why it's critical that you always verify your locate and mark the sonde's position where the signal is highest. In the past few minutes, you've seen the receiver's main features. You've seen what they are. You've seen how they work. And you've seen how they work together to help you evaluate the signal you're tracing. To get the most out of your receiver, you need to read the operator's manual before using the receiver on a job. The operator's manual contains information not included in this video and will help you obtain greater efficiency and accuracy with your receiver. And always remember this: if the receiver's on-screen readings are all in agreement with one another, there's a high probability that you have a good locate. But no receiver can guarantee a perfect markout every time. You can never be certain of the utility's location until you expose it. As with any new piece of equipment, there can be a bit of a learning curve. We hope this video helps straighten out that curve just a bit. On behalf of everyone at RIDGID SeekTech, we appreciate your business, and we thank you for watching this video.